We're going to begin two sections on the lithosphere, how rock is shaped into a wide range of landforms. And this is going to cover exams 3 and exam 4. And so I'm going to start with lecture number 1 for exam 3, Earth materials, the types of rock found on Earth. Now, all rocks fall into 3 categories or 3 classes of rock. And I'm going to begin with igneous rock. Now, this is rock that is cooled from the molten state. I want to give you some terminology in regards to melted rock. Now, we use the term lava when you've got rock in its molten state, but it's flowing at the Earth's surface. So here we've got lava flowing out of a volcano. And so that's the term that we use when we see lava at the Earth's surface. Now there is another term, and we use the term magma when the molten rock is not at the Earth's surface. It's actually deep within the Earth's surface. So, it can be a mile or less than a mile or several miles, 40 miles deep. So, at any depth, deep within the Earth, we use the term magma. So since we've got two, different, terms regarding where the molten rock is placed, it should, indicate that there are 2 different kinds of rock that are formed from the cooling. So there are 2 kinds of igneous rock. The first kind is called extrusive igneous, and so extruded at the Earth's surface. And so this is igneous rock that solidifies and cools from lava flows at the Earth's surface. And the lava is going to cool at Earth's surface temperatures. And so this is very unusual, in geology and geologic time scales. We're actually creating rock within hours or days. And yeah, so so because the lava is cooling right at the Earth's surface, you could actually see here's a lava flow flowing into a parking lot in Hawaii in 2014. You can actually see it, it's kind of darkening and crusting over and cooling at the surface, and then it kind of cools into the interior. So that happens pretty quick. And here's an example in the figure here, of a lava flow like from Hawaii, which is so common. And this will cool very quickly and create extrusive igneous rock. Now, there is a relationship between cooling time and the size of the mineral grains that are found in the rock. And so since extrusive igneous rock cools very rapidly, the individual mineral grains are tiny. There is absolutely no time to form big crystals that you can see. So we call any type of extrusive igneous rock very, very fine grained. The individual mineral grains are like little pinpricks. There's just simply no time for them to grow. Now, for each rock, I'm going to give you the most common name or named rock. Now, the most common rock that forms from lava flows by far is a rock called basalt. And it's very dark in color. It's dark brown to black in color. And as I said, it's very fine grained. And here's Hawaii again. And so that lava flow eventually flowed over that parking lot and solidified into basalt. And here we can actually see some really, some basalt forming, and it's going to cool from the surface into the interior. And so eventually this lava in the interior is going to cool within a few more hours and create basalt rock. Now I'm going to be talking a lot more about basalt rock in later lectures, so we'll see this again and again. All right, now the second type of igneous rock is intrusive, and so this is magma. Now, so magma is going to cool and solidify below the Earth's surface, deep within the Earth, at higher temperatures, deep within the Earth. And so it's going to cool slowly at Earth interior temperatures. And so this is, normally how we think about rock being created. It takes, hundreds of millions of years, right, for the magma deep within the Earth to eventually cool and create a rock. And so here's an example of what was once a mass of magma deep within the Earth. Now the the source of heating moved on through plate tectonics and had moved on, and so the magma now finally starts to cool, but it's cooling very, very slowly. And so it has, plenty of time, millions of years, hundreds of millions of years, for the individual mineral grains to grow. And so typically, intrusive igneous rock has large mineral grains or crystals, big crystals. Now, the most common type of intrusive igneous rock is granite. Now, everyone's familiar with granite. It's very popular. It's a beautiful rock, and it's used, for granite, countertops, and people love it because of the big crystal grains. So it's very, very, well-known rock. Well, anyways, what winds up happening is once we create a big mass of granite deep within the earth, it's got a term in geology. It's called a batholith. And so it's like a large body or a very large mass of intrusive igneous rock. And invariably, it's going to be a big mass of granite. Now, this can be the size of a state, so it can be very, very big. It's called a batholith. All right, here's an example. I mean, so many, beautiful types of granite, but I just wanted to show you, a kind of one that's close by in the Texas Hill Country. If you ever go near Austin, you're actually gonna see granite, and it's pink granite. And so this is, a nice example. You can see the large crystal grains here. Some that is exposed from erosion in the Texas Hill Country. You can see the large crystal grains. Well, I do have a question for you. If granite only forms deep within the earth, how do we have granite at the earth's surface? And there are two ways. There are two ways to get granite at the earth's surface. What we can do, and one of our next topics is plate tectonics, but we could have massive pushing up, all right? Pushing up, and we can actually uplift this batholith so it winds up at the earth's surface. And once it's at the earth's surface, it's going to wind up forming a big, big mountain range. So you can uplift it to get it at the earth's surface. Or another way, or it could be in combination too, is what you do is you get all of this overlying rock, it could be miles of it, and then over long, geologic time spans, you wind up eroding all the overlying rock and you expose the granite. And then the granite will eventually form, again, a very large mountain range. Right. And we still call the mountain range a batholith. And I want to show you some batholiths here. I mean, a really famous one is in Idaho in the Northern Rockies. Part of the Northern Rockies are a beautiful example of intrusive igneous rock that has made its way to the surface, forming a big mountain range. So here we are here in Idaho. This is a picture I took, flying over Idaho. Now, another really famous example are the Sierra Nevada mountains of California. And again, this is an exposed batholith that's been uplifted. And so you wind up with very, very large areas of granite that is exposed as big mountain ranges and batholiths. And those are just two very big ones in the United States. Now, let me move on to the second class of rock. It's called sedimentary rock. And over long periods of time, sediments become deposited on the Earth's surface. And then through time, they can become compacted if you just add more weight on them, compacted, and then they can be cemented together by some other form of rock mineral like iron or calcium carbonate, can be cemented together into rock. So you take sediments and you turn them into rock. Okay. Now the thing is, since sediments are, deposited or laid down on the Earth's surface, you can actually see the layers of sedimentary rock. And the term that is used is strata. And something that's stratified, is layered. And so you can always pick out sedimentary rock because you can see the layers, as the different sediments word laid down, right? Laid down and then eventually hardened or lithified into rock. And I mean, here's just one very beautiful example of the sedimentary strata that's exposed in northern Arizona, where the Grand Canyon has cut down over 1 mile deep and exposing all the sedimentary strata there in the Grand Canyon. All right. Now, I'm just going to give you some very common rock examples. And one very common sedimentary rock is sandstone. And sandstone is nothing more than sand grains, masses of sand at one time that, again, become cemented together and forms a rock. So usually sandstone represents, former, ancient beaches from millions of years ago, or, ancient sand dunes, in different areas where the climate was much drier. And so you can actually hear, so you can actually see the individual sand grains, so it's a nice example of sandstone rock. I just want to show you now, we're in Thibodaux in South Louisiana in the Delta. We're just all sediment. But by the time you get up to about Natchitoches in central Louisiana, it's the Louisiana Hill Country, the Kisatchie Hills of Louisiana. And so, this is where we actually get rock that was deposited, 65 million years ago. And it's white sandstone rock. And here's an example here in a creek, and it's exposed, and you can see how beautiful white it is. But remember how you get sandstone. It's either from sand dunes or a beach. And what's kind of remarkable is that 65 million years ago at Alexandria, Natchitoches area in central Louisiana, sea levels were higher, and that was the beach there. And so kind of think about the beaches that we have today along the Gulf Coast, the beautiful white sugar sand beaches. Well, 65 million years ago, they were far inland in central Louisiana, and today we've got the former beaches, the beautiful white sandstone. So that's kind of neat if you ever make it up to the Kisatchie Hills in central Louisiana. I want to give you a second example of sedimentary rock, and that's shale. And this is clay, clay deposits that are compacted over, long periods of time and represent areas that have a lot of clay, like where we are now in the deltaic plain of Louisiana. So if we blink our eyes in another couple 100 million years, where we are today is eventually going to form shale. So it represents areas with a lot of clay, like marshes and swamps and deltas, and we're on the Lafourche Delta Plain right now. And so if you think about the color of clay, the rock form shale, is kind of the same color. It's, gray, from light gray to dark gray to even to, black in color. And so there is a kind of gradation, but that's it. And since shale represents clay that's been compressed or compacted, the individual clay layers wind up, in its rock form, becoming very flaky. It's said to be very fissile, and you can kind of see how it flakes off very, very easily, just because it was compacted layer by layer, and so it's said to be very fissile. And that'll come back to us again in a few minutes. Right now, I've got a third and final example of sedimentary rock. Now, there are more, but I'm just giving you the most common types that you might encounter in your life. Now, the third sedimentary rock is limestone. Now, this is very different from, just having, sand deposited or clay deposited. This is much different. Limestone actually represents marine animals, right, that die in shallow ocean waters, and their skeletons are deposited into the mud in the shallow seafloor. And so usually it's on continental margins, where it's only 100 or 200 or 300 feet deep. So it's going on, right now. Marine animal skeletons are deposited into the mud on the continental shelves, and then over long spans of time, we wind up creating solidifying or lithifying this rock. And so limestone, yeah, if you think about it, what marine animal skeletons are. I mean, you just think of what you know about a clam or an oyster shell or a shell. I mean, it's hard rock, and so the shells of marine animals, like clams or oysters, if you think about it, they're hard like rock, and the rock mineral is calcium carbonate, right? That's what the shells are made up. And so, it becomes lithified or hardened with the mud in the shallow seafloor. And so very often, limestone is fossiliferous. You can see all of the shells here. And if you think also of the color of, a clam or an oyster shell and our other shells, I mean, they're kind of whitish to gray in color. And so the limestone is typically whitish to gray in color. And so where does the calcium carbonate come from? I mean, these marine organisms actually extract calcium carbonate from the ocean waters and build a protective shell. And so eventually when they die, they become incorporated in the seafloor and eventually hardened. Now again, since limestone, only forms, in shallow ocean areas, how do we have limestone, on the Earth's surface? As a matter of fact, there's limestone on the top of Mount Everest. So the question again is, I mean, if limestone only forms in shallow ocean settings, how do we wind up, getting limestone at the Earth's surface? And again, there are two ways, and it's kind of just like pretty much what we talked about in regards to getting granite to the Earth's surface. You uplift it, and again we'll be doing plate tectonics and earthquakes and fault lines and things like that. But a good example of uplift is the peninsula of Florida. Now during different geologic periods, sea levels were much higher. And so, so all of what we know of Florida today, was a shallow sea. All right. And this is basically the Florida platform here. And so it was all covered, very, very shallow. And so what we wound up is, creating a limestone platform. And then it was uplifted. Now, this is right here is the continental shelf. It's still underwater by a couple of 100 feet. But obviously today, this is a little bit higher elevation, right? And so now we've got the Florida Peninsula, just above sea level. And so you can uplift continental shelves to get the limestone at the Earth's surface. Now, way in the interior, I mean, that is a coastal setting here, but during different geologic periods, sea levels were much higher. And here's an example of the Cretaceous period. Sea levels were very, very high, and we wound up with shallow oceans, forming the interior of present-day, North America. And so during this time, we had these shallow seas, depositing limestone. And so now, of course, sea levels have dropped, exposing the limestone. Now, there are other limestone areas, in the eastern and western United States, but they're smaller scale. They were smaller scale basins, low-lying areas that were also filled with water that aren't shown, and also forming limestone. So it's not just right in through here. There were other basins that filled with water that are now major limestone areas. The third and final class of rock is metamorphic rock. And you can take any pre-existing rock, even a metamorphic rock, and you can alter it by the tremendous heat and pressure within the earth. And this is a result of, deep burial, with plate tectonics, the movement of the plates, and mountain building. And so, with intense pressure within the earth and intense heat, you can take any pre-existing rock, right, and alter it and turn it into a metamorphic rock. Now, the metamorphic form of the rock is always stronger than the original rock. You wind up creating, new, rock minerals, and they're always stronger than the original rock. Now, there are many, many examples. I'm going to just give you, I think, two All right, examples of metamorphic rock. And I'm just giving you two that I know you're familiar with, that I know that you will see, when you in the travels in your life. All right, marble is a metamorphic rock. All right, marble. And so marble is the metamorphosed form of limestone. Right. And so a lot of times when I'm traveling, I see limestone and marble, kind of in juxtaposition to one another. Usually the limestone is kind of in the valley and the mountains are the marble. It should kind of make sense. I mean, how do you make a mountain? I mean, it's through intense pressure and heat and uplift and plate tectonics and folding and faulting. And so usually the mountains are marble, and the surrounding area that hasn't been modified by the intense heat is the limestone. And here's some white marble here. It comes in all different colors. Here's some examples. Yeah, and so in the Mediterranean region, there's a lot of limestone. Limestone all over the earth. But when I was traveling, in the Mediterranean region, I was just kind of taken aback, that the marble mountains were basically all gone. Particularly in Greece, and you drive down the road and say, "Where's the mountain?" And it's all been quarried. It's all been quarried. So, and here's we're hiking in Italy, and you can actually see this white. I just happen to have white limestone here, but it can take on various colors, based on minerals. But here's a big, piece that was quarried here. But anyways, if you kind of think about, the ancient temples and monuments, in the Mediterranean lands, it's all marble. It's all marble. So these mountains have been quarried for, well over 4,000 years. So it's no wonder where if you go to Greece, I mean, you can, the mountains are pretty much quarried away. Not all of them, but I mean, you'll see this a lot. It's kind of neat to see that. All right. I just want to give you a second example of a metamorphic rock that I know you're familiar with. And I know you know marble. Now, another metamorphic rock is slate. All right, slate. And here's some examples of Vermont slate. Vermont slate. So here we are in Vermont. And it has different colors. Usually it's kind of grayish. But if there's some iron minerals that get in it, it'll kind of tint it, purplish or reddish or what have you. And so a slate is the metamorphic form of shale. So you get shale and you expose it to intense, heat and pressure, and it becomes a stronger rock. But the thing is, it's still fissile. All right, remember, shale is flaky and fissile, but now you wind up kind of with a stronger form. All right, a stronger form, and so you can wind up, cutting slate into big slabs. Slabs of any size here, but we've got an inch or 2 inch, nice slabs of slate. And you're familiar with slate because you can cut it into thin layers, but it's still quite strong, and use it, and you've seen it as slate roofing tiles that are supposed to last a lifetime, and that's beautiful. And what we have here is actually what we call flagstone, just pieces of random pieces of thick slate, maybe an inch or 2 thick, and you put it down for patios, this beautiful patios, and so it's called flagstone patios, slate patios. Very, very expensive, but very, very beautiful, and that's what this slate is going to be used for. And lecture 1.